All right, the day has come. We're back to proofs. And I told you this is my favorite chapter, so I am so excited to start doing some proofs. Now, in this chapter, well, we just got done talking about congruent triangles. In congruent triangles, all their corresponding parts are congruent. Every single corresponding angle, every single corresponding side. But the good news is, to prove triangles congruent, we don't need to show all 6 things. We don't need to show every corresponding angle is congruent, every corresponding side is congruent. But there's just certain combinations of sides and angles that allow us to prove triangles are congruent. In other words, with these certain combinations of sides and angles, it can't be anything else. Like, it would have to be congruent, because if these things are congruent, there's no other triangle it could be. And so the first one we're learning today, and it's just one today, is side angle side. And so the key here, though, is side angle side. It has to be all right in a row. In other words, it's 2 sides with the included angle. Or in other words, the sides are like the sides of the angle. So look here. See how it's like side, angle, side? That the sides are the sides of the angle. It can't be like this angle with the 2 sides, because that would spell a bad word. A, S, S in that order. So, so it has to be SAS. When we have these theorems, the initials, the names of the theorems, reflect directly on the triangles that we're proving congruent. So SAS, all in a row, side, angle, side. So when we have diagrams like this, there are a couple things that we can mark on our own that aren't marked here. The 2 things we can mark are, number 1, vertical angles, and number 2 is a shared side. We'll get to that in a minute. So this first one here, notice how these are vertical. In other words, that angle would also have to be 90 degrees. So in that case, we do have side, angle, side. And so I was just checking. Sometimes it says, oh, we can't write a congruent statement. There's no letters there. So we would say side, angle, side. Yes. This one over here, we have these vertical angles, side, angle, side. Ooh, but over here, it's not the same sides, is it? Don't look at that bad word. So this was no, or not enough information, right? This one over here, again, I like writing right on there, ASS. Nope. Right? So this is a no. And this one, now notice here's that shared side I was talking about. See how this side is a part of the top triangle and the bottom triangle? Obviously, it's congruent to itself. We talked about reflexive property before. So side, angle, side, side, angle, side. Side, angle, side. Yes. Oops. All right, now in these problems, it says, what other information do you need to prove that these 2 are congruent by side, angle, side? So this one isn't necessarily what do we need, because that's there. That's there. These 2 things that we marked there, that we talked about earlier, those are there. What do we need? What we need are these 2 angles, because that would give us side, angle, side, side, angle, side. So we need angle EFD congruent to angle GDF. That's what we need. The common side is already there on the diagram. Same thing for this one. That's already there. Side, angle, side, side, angle, side. We need those sides. We need to know that LE is congruent to BN. That's what we need. All right, so now we're going to do proofs. Now, these proofs are so fun because we only have one theorem so far, so they are all going to be side angle side. And so there's kind of quite the pattern recipe to them. In other words, we need to show congruent sides, congruent angles, congruent sides, then the triangles are congruent. So we have our given information marked. So I'm going to put that in here. So we have BC congruent to DA. We have angle CBD congruent to angle ADB. So that's given. And so you can see what we have, right? We have side and angle, and we have side and angle. We need this third side, right? So that is reflexive. That is part of both triangles. So we can say BD congruent to BD, reflexive. And now we can say those two triangles are congruent. Now, whenever we write a congruent statement, I'm not so particular about like, when we write two sides, but when we write the triangle congruent statement, we really said like you have to say it so that the corresponding parts match. So in this case, it's given, right? But later when it's not given, we need to make sure we write it correctly. And then we just write SAS. That's it. Congruent by side angle side. Let's try this one now. Let's try this one. Statements, reasons. Okay, so we have BC congruent to DA, and we have BC parallel to AD. Oh, why did I write congruent? It's parallel. Okay. Now, I look at my drawing and I see, oh, I'm going to talk about that. Before you talk about parallel, I'm just going to say AC congruent to AC, reflexive. Now, what we need, because these parallel lines tell us different things, right? But what I need side, angle, side, right? Or side, angle, side. And so I need angle BCA congruent to angle DAC. And we can say that they're congruent because if these lines are parallel with the transversal, they are parallel lines, alternate interior angles congruent. And now we can say triangle ABC congruent to triangle CDA by SAS. Like I said, right now it's easy because we only have one theorem. Oh my goodness, how many, I guess I had to put a bunch of problems on here. Right now we just have the one theorem, but later we'll have a lot more ways to prove triangles congruent, so it gets a lot more interesting. Okay, AB congruent to CB, angle ABD congruent to angle CBD. And those are all marked on the diagram. So now we could say BD congruent to BD, reflexive, that one. And now we can say triangle ABD congruent to triangle CBD by SAS. All right, this one is a little tricky. I'm going to show you why. Let's see. Given information, RO perpendicular to MP and MO congruent to OP. All right, so everything is marked on our diagram. So if RO is perpendicular to MP, we know that it makes right angles, right? That's our perpendicular means right angles. So we can say angle ROM and angle ROP, right angles. And perpendicular means right angles. And this is where it gets, you know, you have to be particular. We can't just say they're congruent. Once we say they're both right angles, now we can say angle ROM congruent to angle ROP, and that is all right angles are congruent. So now we have the angles are congruent, those sides are congruent. Now we need to say RO congruent to RO, reflexive. And finally, we can say triangle MRO congruent to triangle PRO by SAS. Finally, this is a cool one. Notice we don't get the usual congruent information, but they're talking about midpoints. So let's see. O midpoint of AY and O midpoint of ZX. All right, so midpoint cuts it in half, right? So we could say OX congruent to OZ. And we could also say OA congruent to OY. Now, they are all radii. You know, if you put it all in one giant statement, I would be okay with that. But midpoint divides segment in half or into two congruent statements. All right, now 3, we have two sides, we need the angle. Well, those two angles, so angle XOY congruent to angle AOZ, and that's vertical angles congruent. And now we can say triangle ZOA congruent to triangle XOY by SAS. So, little taste of proofs, and you can see, you know, our goal is always the same, to prove the triangle's congruent by SAS. And so we need the 2 pairs of congruent sides and the pair of included angle.